All right. Hello.
Hello.
All right. So, okay. Sunny days, clouds away, on my way to where the end. All right. Okay. So we're going to talk about some inflection points for those people that are actually at home, not doing any work, just sitting there chilling. Okay. So I'm not calling out anyone particular in here that forgot to come to Saturday school and bring snacks. Okay, I'm not calling out anyone like that. Okay, so I'm not gonna put anyone on Front Street there. So hopefully everyone is going to be here for the next one. Anyway, all right. So inflection points. I talked about this the other day. Inflection point is where it's going to change in concavity. Suppose f is a function that is differentiable on an open interval from a to b containing c, then the concavity of f changes at point c, comma, f of c, then is a inflection point. So remember, let's throw up those gang signs. So when it changes from concave up to concave down, when my finger and thumb actually connect, that's the inflection point. Okay? Concave up to concave down. So changes. All right, so let's take a look at, do I have a problem on this one yet? Condition, okay, let f denote functions that is differentiable on a to b containing c, as c, f of c is an inflection point of f, then either f double prime of c is equal to 0, or f double prime of c does not exist. Okay. By not existing, that goes back to my critical numbers. Remember, a critical number is when my derivative does not exist, right? So derivative does not exist or derivative equal to 0. That's critical numbers. So on this one, it also must include double prime not existing at some number. Step 1, find all numbers of the domain which that f double prime is equal to 0 or that it does not exist. Use the test for concavity to determine concavity of f on both sides of each of these numbers. If the concavity changes, there is an inflection point. Otherwise, there is no inflection point. So what would that be if there's no inflection point? So it's just all going to be the same concavity, isn't it? Yeah. Even though I'm going to have some critical number there, but my concavity is going to stay either positive or negative. Okay, find the inflection points of this. So first, let's start off with my first derivative. So f prime of x is 5 over 3 x to the 2/3. Very good. Okay. So, is there places on this one where it is not allowed? 0. I'm allowed 0 here. Oh. It's not a negative. If it was a negative exponent, then I would go to the bottom where I would not be allowed that. Okay, so this is first derivative, right? Now we're going to go second derivative. So double prime, f double prime of x is equal to, what's that going to give me? 10 ninths? 10 over 9, x to the negative 1/3. So there's my double prime. And now given that, I set that equal to 0. So now I'm going to rewrite it as I do it. So 0 is going to equal 10 over 9, that's a 9, x to the 1/3. Right? Okay. So
That means it just can't be 0.
Can't be 0, right? So this one, so x cannot be 0. So there's going to be a critical number there, right? Yeah. Okay, so now if it can't be 0, I might be able to plug in numbers on either side. Right? I could check numbers on either side. So if I try and solve for this, I multiply both sides by 9x to the 1/3, but anything times 0 is? 0. So it's going to be 0 equals 10. I don't have any variables, right? So this is the only number I have. So we're going to check concavity on that. So if I plug in 1, okay, 1 into my double prime, so f double prime of 1, okay, is going to give me what? 10 over 9. It's going to be positive, isn't it? Say yes.
Yes.
That's going to be positive. So positive 1 right here, right? That x is going to be positive 1. Cube root of positive 1 is 1 times 9, so it's 10 over 9. So at my critical number, so this is of f double prime, critical number 0, 1 is going to give me a positive number. How about negative 1? Negative 1's on the other side, isn't it? It's going to give me what? It's going to give me a negative, isn't it? So I can put negative 1 in here, so the cube root of negative 1 is negative 1. Because negative 1 times negative 1 times negative 1 is negative 1. Yeah? Okay, good. Okay, so negative 1 here, so that's going to make it positive 10 over negative 9, so that's a negative on the other side. Okay, so that means it's changing concavity at 0. Okay, now, gang signs here. At 1, what does a positive concavity look like? Okay, I'm seeing a bunch of different gang signs. We should all be in the same gang here. Okay, positive, remember, we're looking at the space above your hand, okay? The space above your hand is my concavity. So a positive would be here. That means I have a minimum here. Okay? Gang sign over here at negative. That means that it's opening up down. That's my negative. So that means I should have a max. Right? So at this point right here, I know that at negative 1, it's going to be a concave down. And at positive 1, it's going to be a concave up. Yep. Does that make sense? Okay, so if I want to find the points in which that actually does that, I can go through and solve for that. Okay, to find my mins and maxes, all that good stuff. But, you know what? It only asks for concavity here, or inflection points. So that's the only one I got. So, here it is. Obtaining information about the graph of f from the graphs of f prime and f double prime. So if this is f prime, so that's a graph of the derivative, right? So I know, given the graph of derivative, right here, that's where my f prime is equal to 0, right? Okay, so that's going to be a min or a max. Think about my numbers here. Think about the numbers. Think about the numbers. On the left side of 0, these numbers are positive. These are positive right here, right? On the right side of 0, it is negative. So right here is negative, right? Okay. So right here going from positive to negative, that should be a max. Okay. Now, let's see also. Over here, now, this point is where my derivative is equal to 0, isn't it? The slope of the derivative is equal to 0, right? Because that's what we're finding. We're finding the slope of the slope, right? The slope of the derivative right here is equal to 0. So that means at 1, there should be some critical number for this. Right here at 1. There's my 0. Okay? So I know I had a max right there. But over here, this point right there, on the left side of this point on my f prime, on the left side, these numbers are negative. And on the right side, they are, right? It's positive right there. So it's negative because it's down here. It's positive because it's up here. So if it goes from negative to positive, that should be a no, we're not thinking concavity. This is the first derivative still. First derivative. So if the slope, it's going to be a minimum, right? So if it's negative and it's positive, so that's going to be a minimum, right? Now, let's go ahead and take a look at this one then. So we said this should be a max. This should be a min. Okay, so change in concavity. So I have right here. Okay, there is my two critical numbers right here. All right, so on this side of my critical number, it is negative, right? And on this side over here, it's also negative, isn't it? All right, so over here, this is going to be, on the left side of 1 is a negative, but the right side of 1 is a positive. So, looking at this, there is a change in concavity. That's where I throw up those gang signs with both hands, right? A concave up and a concave down. So it's changing in concavity there. There we go. Changing in concavity. So if it's not, then it's going to go something like that. So it's these ones right here. At this point, it's not changing concavity. So because of this, I do have a max, but it's not changing concavity. Does that make sense or no? Because we just did a whole bunch of stuff that we've done together. Ask me questions, please. Something. This is not. I'm hoping it's that easy or that confusing or I don't know.
Why is there a change in concavity at the max?
What?
Why isn't there a change in concavity at the max?
Okay, why is there? Okay, so now, because of this, if you think about it,
Oh, it's negative, negative.
yeah, it's a negative, negative. It's negative, negative. So if it's negative, negative, what does that tell me?
That it goes down.
Right here, isn't it?
Yeah.
Negative, negative, isn't it? So on both sides, it's concave down. Yes? So if I take this information, both sides of that, it's concave down. But does that fit over here that says that this is supposed to be a max? Yes, because we throw up those gang sides. If it is a negative concavity, right, it's opening down, that means that my fingers say that this is going to be a max at 0. Yes?
Yes.
Okay, throwing up those gang signs for this. Does that make sense now?
So,
Yeah.
You're gonna get demonetized
Why?
because you're saying gang signs.
Okay. You know I'm not monetized as that. Okay. They might take my store offline though.
yeah.
Okay, so. I know, right? Yeah. Anyway, but still. Someone would actually have to watch this video to be able to, actually, say I'm being demonetized. Anyway, alright, we okay? Okay, let's see. Okay, so, from those graphs, did we figure out the critical numbers of F? Yes. Okay, where was F increasing? Oh, we filled that in. Where was F decreasing? We filled that in too. Okay, and what values of X does it have a local min? Alright, what values of X is the local max? Alright, where is it concave up? Alright, we figured that one out. Where is concave down? Any inflection points? Changing concavities? Yeah. We just answered all those questions. So, second derivative test, define local extrema. Okay, there's my thing again, right? So with my derivative, my first derivative equal to 0. My first derivative equals 0. I could use second derivative, plug in the c value into the second derivative, and that's going to tell me if it is, like this one, if it is positive, right? If it's going up, if it's positive, it's going up. So that means that's going to be a concave up, so that makes it a minimum. So we're using the points, the critical points from my first derivative. Critical points from my first derivative. So, I don't even think it says it on there. Maybe we should write that on there. Critical points from my first derivative for the second derivative test. So critical points from the first derivative gets plugged into the second derivative to test concavity. And that's going to tell me if it's going to be mins and maxes. Okay, let function at f prime, f del prime exists at open intervals. Suppose C lies in A to B, critical numbers at f. Okay, we've talked about the gang signs already. Determine where this is going to be concave up and concave down. Okay, so let's go ahead, find the first derivative. So f prime of x is equal to 1. Okay, derivative of negative cosine? Negative sign, right? So it's negative 2 sine of x.
Isn't derivative of cosine negative sign?
Okay. Oh, negative cosine is positive sign. Thank you.
Yeah.
Thank you, thank you. See?
Oh.
Yeah. So negative cosine's on the left of the wheel. And then it goes back up to positive sign. There we go. All right, so there's my f prime. All right, so now let's go ahead and set that equal to 0 because I need my critical numbers. So 0 equals 1 plus 2 sine of x. So that's going to be a negative 1/2 is equal to sine of x. Now, over the interval from 0 to 2 pi, that's my whole unit circle. What places? Now, first, think about sine is which value, the x or the y? Y value. Now, where are the y values negative? What quadrants?
Quadrant
3 and 4, right? 3 and 4. It is below the x-axis. All those are going to be negative, right? So, where's sine going to be equal to 1/2? Where's sine in the quadrant 3 and 4 equal to negative 1/2?
it's gonna be at like pi 7/8 or something.
Say it, what?
7/8? Pi
7.
12 or something like that. Hold on.
7/6.
7 pi over 6.
Oh, yeah.
Because if you think about it, okay, remember, it's 1/2 is smaller than 3 over 2, right? So that means that I want my sine value to be less, so that means the cosine has to be bigger. So that means it's going to go more to the left. And it's not down more, it's more to left more. So on my unit circles, I only have, basically I have the pi over 6, the pi over 4, and the pi over 3. So on that one, so it's going to be right there. So in quadrant 3, 7 pi over 6. Now, what about quadrant 4? 11 pi over 6, right? It's almost all the way up to 2 pi, isn't it? So it's 11 pi over 6. There we go. All right, so we got all that taken care of. Okay, so let's start off with figuring out inflection points. So I need a second derivative. So second derivative. So the derivative of sine is cosine, right? So f double prime of x is equal to 2 cosine x. Okay, so set that equal to 0. Okay, is there any places where cosine is going to be undefined? No, cosine's not, right? So this one, so divide both sides by 2. So where is cosine equal to 0? On my entire wheel.
Pi halves.
So it's pi over 2 and 3 pi over 2. Very good. So I got inflection points. Okay. So those are places where it's going to be changing concavity, isn't it? Okay. And second derivative test to finding local extreme values. Okay, we'll get to that one, but I still am trying to answer the first one. Okay, concave up and concave down. All right, so inflection points. That means that it's going to change in concavity. Let me see. Insert page after. So it's going to look like this. So here is my 0. Here is my 2 pi. Here's my pi over 2, and 3 pi over 2. So I stretched it out so we could see this. So we said that there is critical numbers at where? First derivative. 7 pi over 6. So 7 pi over 6 is going to be right here, right?
Yeah.
Okay. 7 pi over 6. Where's the other one? There we go. 11 pi over 6. Those are my critical numbers. All right, and changing concavity. Okay, we have pi over 2. So here's what, it's supposed to be blue. So right here, so pi over 2 and 3 pi over 2. So I've changed it in concavities at those points. So let's use second derivative test now to tell me if this is going to be a min or a max. So I should have mins and maxes at 7 pi over 6 or 11 pi over 6. So let's use second derivative test. So my second derivative test says that it was it 2? So f double prime of, we're plugging it in right here, 7 pi over 6 is equal to, it was 2, right? 2 cosine of 7 pi over 6. All right. So, cosine 7 pi over 6 is, okay, think about it. Where is 7 pi over 6? Quadrant 3. It's quadrant 3. Negative, negative, right?
Yeah. So it would be negative.
So this is going to be a negative.
Right.
So if it is negative, that means my concavity is opening down. So this has to be a max. So this is going to be a max right here. So I'm going to put this one up here. Wait, yeah, there we go, closer. All right, and let's do the other one. So f double prime of 11 pi over 6 is going to give me 2 cosine of 11 pi over 6. So 11 pi over 6 is quadrant 4, which is going to give me a positive number. So it's going to give me a positive value. So if it's positive, that means it's opening up. And with my hand, okay, it's going to be a minimum. So down here, I should have a minimum. So it's changing concavity at 3 pi over 2. Right? Changing concavity at 3 pi over 2. So it should look like this. So over my interval, I know it's changing here. So, sorry. Let's do this one. All right, so it should look like this. So, this is what my graph should look like. I know I have a max here. I know I have a min here. Yes? So even if this side right here keeps going, if this goes up right here like this on the other side, okay, that's still concave up, isn't it? Okay. All right. Does this make sense? Okay, so that's basically what we're trying to get at. Okay, I think I'm going to do this again tomorrow. I think I still have one more set. So don't forget, like, share, and subscribe. Hit that notification button. And advisory today. And we need to talk about when we are